Early morning, August 5th, 2026. While most of us were asleep, a piece of metal weighing roughly 4 metric tons, moving at over 5,000 miles per hour, slammed into the surface of the moon. No warning to the public, no live broadcast, just a quiet, violent impact on a world 240,000 miles away. But here's the wild part. Astronomers knew it was coming. They tracked it for months, and when it hit, some of the most powerful telescopes on Earth were already pointed at exactly the right spot. So what actually crashed into the moon? What did scientists see? And why does an accident like this actually matter for space science? Let's break it down. The object wasn't an asteroid, and it wasn't aliens. It was leftover space hardware, specifically the upper stage of a SpaceX Falcon 9 rocket. This particular stage had launched back in early 2025, carrying lunar landers into space as part of a mission. Once its job was done, the empty stage was left drifting. No engines, no control, just floating through space on a long, slow orbit. For over a year, it quietly looped through space until its orbit finally intersected with the moon. Independent astronomers, including researchers tracking objects that aren't officially monitored by government agencies, picked up on the object's trajectory months in advance. By analyzing its orbit, they were able to predict almost exactly when and where it would hit. This was a spent Falcon 9 upper stage that unintentionally collided with the moon, leftover space junk, quietly completing an unplanned collision course. Here's where it gets genuinely impressive from a tracking standpoint. Astronomers pinpointed the expected impact site months ahead of time, a region near the Einstein crater on the moon's western limb, a spot that's notoriously difficult to observe from Earth because it sits right at the edge of what we can normally see. The predicted time of impact, roughly 2:35 a.m. Eastern Time, at a speed of about 5,400 miles per hour, nearly 7 times the speed of sound. Because the impact happened on the side of the moon that's hard to view directly from Earth, there was no visible flash confirmed by direct observation. Confirmation had to come from something more precise: telescope detection of the impact's aftermath. That's where some of the world's most sensitive telescopes came in. The European Southern Observatory's Very Large Telescope, based in Chile, was one of the key instruments pointed at the moon during the predicted impact window. And it worked. Scientists confirmed they detected spectral lines of sodium and lithium gas in the impact plume, signatures that lasted for roughly 5 to 10 minutes after the collision. In simple terms, when the rocket stage slammed into the lunar surface, the force of the impact vaporized material instantly, kicking up a cloud of gas and debris. That cloud contained trace elements, sodium and lithium, that showed up clearly in the telescope's spectral data, even though the flash itself wasn't visible to the naked eye from Earth. This is a big deal for scientists because it means the impact wasn't just confirmed, it was actively studied while it happened. Real data, captured in real time from a genuinely unplanned event. You might be thinking, okay, a piece of space junk hit the moon. Why does anyone care? Here's why. This kind of impact is incredibly rare to study properly because with natural impacts, asteroids, comets, scientists almost never know the exact mass, speed, or composition of the object beforehand. This time they did. A known object, a known mass at roughly 4 tons, a known speed, a known impact angle. That turns an accident into something close to a controlled experiment. By studying the resulting crater and the debris plume, scientists can learn more about how high-velocity impacts actually behave on the lunar surface. Information that helps refine our understanding of crater formation across the solar system, from the moon to other rocky worlds. This isn't the first time this has happened either. During the Apollo era, NASA deliberately crashed spent rocket stages into the moon on purpose, timed so that seismometers already deployed on the lunar surface by earlier missions could detect and study the resulting seismic waves, revealing information about the moon's internal structure. So in a strange way, this accidental impact continues a tradition of turning leftover hardware into genuine lunar science. Here's the part worth sitting with for a second. This piece of debris orbited quietly for over a year before anyone needed to worry about it. And it's not the only object like it out there. As more missions head to the moon and deeper into space, more leftover hardware ends up drifting in long, unpredictable orbits. NASA has stated there was no danger to Earth from this particular impact, and there wasn't. The moon has no atmosphere to protect, and impacts like this don't pose any real risk to us here. But it's a reminder that space is getting more crowded, and tracking what's actually up there, even old, forgotten rocket stages, is becoming a genuinely important part of modern space science. So, to recap, a 4-ton piece of a SpaceX rocket, launched back in 2025, spent over a year drifting through space before slamming into the moon at over 5,000 miles per hour. Scientists tracked it, predicted it, and captured real data the moment it happened. Not a natural event, not a planned mission, just an accident that turned into a genuine scientific opportunity. If you want to keep up with real space events as they happen, hit subscribe to Deep Space Files, because sometimes the most interesting science comes from things we never planned.